Part 2 of the chain rule. So what I've got here are 4 examples that I want to play with, and just do the derivative, and each of these will involve the chain rule in some form or fashion. All right, so let's kind of do the examples. All right, so our first one, we got the derivative of the quantity of 2x to the third minus 5x all to the fourth. And so now one of the tricks of using the chain rule is that basically the identification, you got to identify who's the inside function, who's the outside function. Because the chain rule says take the derivative of the outside, leave the inside function alone, then times the derivative of the inside function. So it's key to know who's inside, who's outside. Okay, so we're going to identify those. Now, the first thing I'm looking at is when I'm looking at the expression, one of the key indicators for me, giveaways, are parentheses. So when I'm looking at parentheses, I'm seeing stuff inside of parentheses, and the parentheses is to the fourth power. So I've got stuff to the fourth power. So the stuff inside the parentheses, that will be my inside function. And what I'm really looking at is that I've got a power 4 outside function. Okay. Yeah, I know I'm using the informal stuff here. I could get really mathy on you right real quickly, but I thought, hey, let's kind of get the idea, and then we'll get more technical as we get comfortable. So that's kind of my philosophy there. I'm going to be using stuff a lot, junk, things, that kind of phrase. But just to know that we could get all technical and actually do this in a very mathematical, sophisticated way. But my philosophy is learn what's going on, get comfortable, then get technical. All right, so I've got stuff to the fourth power. That's my outside function. And then my inside function would just be the stuff that's inside the parentheses. That's my inside function. So I've got a power 4, that's the outside function, and my inside function is the 2x to the third minus 5x. So I've identified who's outside, who's inside. Next step, just do the derivative. So I do the derivative of each piece. And so when I've got a power 4, the derivative of power 4 says bring the 4 down in front, subtract 1 from the power. So I got a new power 3. And so then I've got my stuff in there. I know I've got it. I haven't played with it, anything there, but that's just basically the derivative of the outside part. And then do the derivative of the inside part. Well, that's just going to be a nice 3x squared minus 5, just kind of doing the power rule there. And so now that I've got the derivative of the outside part, and I've got the derivative of the inside piece, let's just put those things together. So the full derivative is going to be this expression at the bottom, the 4 times that quantity to the third power, and then this 3x squared minus 5. So what we're doing is we're bringing the derivative of the outside, the 4 and the power 3. So we're bringing that 4 and that power 3, and then we're putting the stuff back inside, the original inside function. We don't do anything with it. We just do a rewrite there. And then times the derivative of the inside piece. So we've got derivative of outside with the inside left alone, and then times the derivative of the inside. It's like eating that orange again. I'm doing the peeling of the outside part, leaving the wedges alone inside, and then breaking the wedges apart for that second piece. Okay, so for our next example, we're doing the square root of 3 minus x to the fourth. Just like when we were doing the power rule, one of the first things we want to do is do a rewrite. Let's rewrite this expression. So square root, we can rewrite it as a power 1/2. And so we're taking the derivative of the quantity of 3 minus x to the fourth to the 1/2 power. So first step, let's identify who's inside, who's outside. Once again, I'm looking for parentheses. Parentheses are always a dead giveaway for me. And so the outside part would be the power 1/2, and the inside part would be the 3 minus x to the fourth. And so there's what I've got. I've got a power 1/2 and a 3 minus x to the fourth as my inside part. Next step, just take the derivative of each one individually. So I bring the 1/2 in front, subtract 1 from the power, so that's why we got a negative 1/2 power. And then over here to the right, when we do the derivative of the inside, we get a negative 4x to the third. And so then what we want to do is put those two pieces all together. So we're doing the 1/2 to the negative 1/2 power. And so that's kind of where I'm bringing the derivative of the outside. And then remember, put the inside piece originally back inside. So that stuff, we don't touch the inside stuff when we do the derivative of the outside piece. then times the derivative of the inside. Okay, so that's the example of this one. And if you want, you could do a rewrite. That negative 1/2 really means a square root because of the half power. And the negative means put that stuff in the denominator. So if you wanted to, and the 2's and the 4's can reduce out, you could do a rewrite there on that expression. Okay, our next example here. Once again, before I do the derivative, I just want to do a rewrite so that it makes it simpler for me. And what I want to rewrite is this fraction here. And so I've got stuff in the denominator, and what I want to do is a rewrite with the power as a negative 4 power. And so now I've got it set up ready to do the derivative. And you might be thinking, well, what's the inside, what's the outside part? Well, what I've got for the outside part is that I've got the common inside pieces right here. So I've got 2.4x squared minus 5. I see that common here. So my outside pieces is my stuff to the 4th power minus stuff to the negative 4th power. And then my inside is a common inside, so I just got that 2.4x squared minus 5. So I'm looking at these things individually. Instead of being so overwhelmed by looking at the whole thing at one time, I'm trying to break it apart. And I'm just thinking, okay, I got something to the 4th power, and then I've got something to the negative 4th power. And I'm just going to take it each separately, each one piece at a time. And then we do the derivative of each piece. And this is a nice straightforward power rule. We get a 4, we bring down, subtract 1 from the power. Bring the negative 4 down in front. That's why this is a plus sign here, because it's the negative 4 times that subtraction there. So we got a negative negative. So that's why you see it a plus 4 here. And then when I subtract 1 from a negative 4, it makes it more negative. So that's why you're seeing a negative 5. And then for over here on the inside piece, that's a nice straightforward 4.8x because we're bringing the 2 down in front as multiplication. All right, so that's what we've got. So I've got my derivative here of the outside part. I've got my derivative of the inside piece. So then what I want to do is just bring the derivative of that outside part, and that's what I've got here. And then what we did is we put the insides back in, and then multiply each of these guys by the derivative of the inside. Okay, so every time I did the derivative of the outside, these power rules, I'm going to have to, each one of these guys have to multiply by the derivative of the inside. Okay, and so that's one of the catches there. So I've got 2 sets there of the 4.8x. Yeah, I know that you could actually have put a big parentheses around there and multiplied both by, by common 4.8x, that's kind of like a factoring out kind of thing. But I just wanted you to bring attention that every time I've got stuff here, power rule kind of thing, that it's that's where the derivative of the inside has got to match up. Now doing the other problem, looking at more of a 2-step process here. We're going to take the derivative, and then because of the vertical line x equals 2 here, that's just telling us that once we do the derivative, the next step we have is to plug in 2. And so that's what I'm looking at here. I did a rewrite. I went from the fraction to a negative 1 power. And so now I've got going to identify who's the inside, who's outside. So the inside piece would be this 4 minus 3x squared because it's inside the parentheses. And the outside function would be the power negative 1 in this case. And so we do the derivative of each of these pieces. So a derivative of a negative 1 power would be negative 1. And then we'd have a negative 2 power because negative 1 minus 1 would be my negative 2. And then over here, a nice straightforward derivative. Remember, derivative of a constant of a number would be 0. And then we've got power rule here for the negative 6x. Now putting those things together, we're bringing in the derivative of the outside. We're putting back in the inside function, and then we're multiplying by the derivative of the inside. And so there's our chain. Well, you could kind of simplify this if you wanted to. Oh, wait a minute. No, I'm not simplifying. Excuse me. My bad. We're supposed to evaluate this thing at x equals 2, so we're plugging 2 in, and then we're calculating it. We're crunching it out, and I get a 3/16 when I do that. So my apologies. I forgot that we had actually to evaluate this and plug this in. That vertical line, x equals 2, means plug it in. Okay, so got to keep track of that stuff. All right, and so then just a reminder of the product rule or the chain rule here, when I'm doing the derivative of a function within a function, it's do the derivative of the outside piece first and then times the derivative of the inside. Okay, so this is part 2 of the chain rule. Hope it helps, and we'll do some more examples in part 3. Thanks.